Welcome to day 2 of our 62-day low-level design mastery course. Today we are diving into one of the most important foundations of software design, object-oriented programming or OOP. This session will set a strong base for all the design work we will do in this course. In this session we will refresh our core understanding of object-oriented programming. We will walk through the 4 pillars of OOP, see real-world examples, compare key concepts, and practice small exercises. By the end, we will be ready to apply OOP effectively in real LLD problems. OOP or object-oriented programming organizes software into objects and classes. It helps us model real-world entities in a structured and meaningful way. With OOP, our systems become modular, easier to maintain, easier to extend, and more aligned with real-world logic. OOP stands on 4 foundational pillars: encapsulation, inheritance, polymorphism, and abstraction. Each plays a key role in creating flexible, scalable, and maintainable systems. Encapsulation means binding data and behavior inside a single unit, typically a class, and protecting internal details. This helps us keep our data safe, enforce rules, and ensure controlled access. For example, in a banking system, we don't expose account balances directly, we update them through methods. Inheritance allows one class to acquire the properties and behavior of another. It supports code reuse and helps us build logical hierarchies. For instance, a user class can be extended into admin and customer classes. However, we must be careful. Deep inheritance can make systems rigid, so we always consider composition first. Polymorphism means one action behaving differently depending on context. We see this through method overloading at compile time and method overriding at runtime. In a payment system, the method like pay can behave differently for UPI, card, or wallet payments. Abstraction is about focusing on what something does instead of how it does it. We hide implementation details and expose only necessary functionality. Interfaces and abstract classes are used to achieve abstraction. For example, a payment interface can have multiple implementations. Both abstract classes and interfaces help with abstraction, but they serve different purposes. Abstract classes allow partial implementation and are suited for closely related classes. Interfaces define capabilities and allow multiple inheritance, ideal when different classes must support the same behavior. A very important principle in modern OOP design is preferred composition over inheritance. Instead of forcing deep classes hierarchies, we build systems where objects collaborate. A car has an engine, that is composition. A car is a vehicle, that is inheritance. As we design classes, we must aim for high cohesion, that is each class having one focused responsibility, and low coupling, which is minimal dependency between components. We avoid God classes, we encapsulate what varies, and we always keep maintainability in mind. Let's look at a familiar real-world example, the Uber ecosystem. We have users like riders and drivers, a ride entity, locations, and multiple payment methods. This structure maps naturally into classes and relationships, showing how OOP aligns with real systems. As a quick practice, we will design an online course system. We identify key entities such as course, student, and instructor, and define relationships and behaviors. This helps us strengthen our object-oriented thinking. These are common interview questions around OOP. Understanding the difference between abstraction and encapsulation, method overloading versus overriding, and composition versus inheritance will help us excel in LLD interviews. Our homework today is to model a library system OOP design. We will define classes, create UML diagrams, and demonstrate all 4 pillars. This assignment prepares us for real system challenges. To summarize, encapsulation helps us protect and bundle data. Inheritance supports hierarchy and reuse. Polymorphism enables flexible behavior, and abstraction helps us hide complexity. Together, these principles form the backbone of good object-oriented design. In the next session, we will move into solid principles, the foundation of scalable and professional low-level design. These principles combined with OOP will elevate our design skills to an industry-ready level.